Hi everyone, this is Giovanni, also known as Crypto Joe 101, and today we're gonna try the impossible. We're gonna try to go from zero to having a smart contract running in a browser on Cardano on the preview testnet, and we will do this using Helios and developing, or Helios, depending on how you want to pronounce it, and we will be using Next.js TypeScript, so very latest framework technologies, so that you can have fun yourself at home. The reason of this video is because for the past year and a half, there have been lots of people saying that writing smart contracts in Cardano is complicated because of Haskell. Likely community effort has developed a number of DSLs. We know Eitghteen, we know Eitghteen. Eitghteen is more like kind of Rust syntax like. Eitghteen is like Python, while Helios leverages a DSL, domain-specific language, that is written in a JavaScript-like way. There is also Plutus from the Harmonic Labs, but without further ado, already the first 30 seconds have gone, so let's jump on the editor. I am not sure I'm going to be able to do this in the 5 minutes, but we'll try to go as fast as possible, but trying to be clear at the same time. So we're going to be using npx to create the project, create next app, and we're going to be using like the latest. Oops, I forgot the name. Cardano SSC Helios 5 minutes. We want to use TypeScript project, yes, lint, yes. We don't want the source, and we don't want the app, and we are happy with the aliases. Now what I have to do is install the Helios library and then launch VS Code. In the background, I'm gonna have like the template that I've already done. I'm gonna be using a couple of snippets of code that I'm gonna just copy and paste straight away in a minute. But this is our new project. There is nothing we have to change. The only thing that we're gonna go is like to go into pages, into index, and we are going to remove the everything in main. We're just gonna create a new main. I'm gonna be developing our project here. Now, before starting, there are a couple of quick things that I want to do. There are a couple of gotchas, you can read it yourself, but because I need to access the Cardano window, the Cardano object into the DOM, I need to specify this in TypeScript to make the compiler happy. And the next thing that I'm gonna do is basically get the network parameters accessible to the app, because we will need to compile to finalize the transaction. We will see more of this in a minute. So the first thing that I'm going to be doing is to create a const just to do this network params. Now the most important thing, we have to do the validation script, right? So the beauty of Helios is that you can actually write the smart contract straight away into your page if you want to do a very quick and dirty prototype. And that's exactly what we're going to be doing. So we're going to be creating a const script, and we start to write it. Helios script, they always start with, what's it called again? I'm cheating, oh my god, spending, right? Sorry. With the declaration that is spending. So the reason, the type of script, and we will be calling spending vault. Vault is just a simple name we're going to be doing, and that's exactly what we're going to be developing. We're going to be developing a smart contract where we can send anything we want into it, NFTs, assets, ADA, whatever we want, and our private key, so our public key, will be declared into the smart contract, will be the only one that will be able to spend this input. So we can send anything we want to this script, and only us from our wallet we can take those things back. So in order to start from this, when we're developing a smart contract in Cardano, you need a datum. A datum is basically a piece of data that is required to access a UTXO in a smart contract. If you're not familiar with those concepts, you have to go and read it. Because Helios made things very, very easy, but if you don't know how UTXO and Cardano works, you need to study it first, otherwise none of this will make sense to you. But let's start. So the first thing that we do, we declare a struct, it is called datum, hours datum. You can call it whatever you want, but it's nice to have the word datum here. So the only data that we have to put in here is like the owner public key hash, and we need to declare a type, pub. We also have to declare the variable that is owner pkh, and the pub key hash is the type of this attribute. Now the next thing that we can do is a struct in Helios can also have methods declared on them. It remains a little bit the concept of object and classes in object-oriented programming. Is not exactly the same, and I'll show you in a minute, because you have to pass the self reference to it. So it's like a method that you call on a struct where self is a reference to itself. So declaration is always func is owner pkh. So we have to check that we are actually that whoever is trying to spend this transaction is actually ourselves. The first thing is in the function in a struct needs to be the reference to itself, and then we need a reference to the transaction as well. So we define the tx attribute of the type capital TX, and capital TX is basically a reference to the actual current transaction, pending transaction. It will return a boolean. So now tx, the object tx, has a nice attribute method that is the is signed by that requires a public key hash as an attribute. So what we're going to be doing is we're going to be checking that the current transaction is signed by our own public key hash. So if the spending transaction is trying to get stuff from the smart contract signed by us, it means that we can validate the transaction and get whatever was sent to the smart contract. And let me just spend 1 second to explain 2 things. When we send stuff to the smart contract, there is no validation. Like, we just send things to the smart contract, right? So smart contract is not executed. But when we try to spend things within the smart contract, so in the UTXOs assigned to the smart contract, the transaction needs to be validated. So in this case, the validation is whoever is collecting those data, those ADA, NFTs, assets, whatever, is it the guy that sent it in the first place? So whoever was declared into the datum. So what we do is we say we say yes if this thing matches. So if the transaction is signed by the public key hash that we declare when we send the stuff to the smart contract, then validate it positively, so the outcome is true, and the smart contract will pass. So this is the first bit, that is the declaration of the datum. The second thing that we have to do is to declare the function main. The function main accepts 3 attributes, 3 parameters, but we're going to be using only 2 out of the 3. We don't need the redeemer. We just need the datum, that is of type datum, capital datum, and then the script context of type script context. Again, a boolean is returned, and all that we have to do from the script context, we have to extract the transaction. So tx, capital TX equal script context dot tx. Declarations, they want a semicolon in the end, and then all that we have to do, as I did here, there is no return. You see, there is no return. So the last instructions in Helios returns the value of returned by the last function. So in this case, it's signed by returns a boolean. The boolean is automatically returned. So in this case, in order to make the transaction, the validation to work, what we have to do is basically to call datum is owner pkh. We don't have obviously to specify self because it's already self, but all that we have to do is to spend the transaction. So right, the smart contract is over. So it's definitely less than 5 minutes, but now the boilerplate is like just calling the smart contract is what is going to take a little bit of time. The first thing that we have to do now, that I love to do as I'm developing, is to ensure that everything is working. So I'm going to be adding an input, a button, because I want to be sure that the smart contract is actually compiled, till is actually working. On click, I want to call the a build method function. Sorry, const build contract is equal to, let's put a nice thing just in case. Now in this case we don't need the thing, I'll stick it because I'm gonna do a little bit of copy and paste later on. On click, I want to build the contract. I'm gonna be needing to do this because I want to be sure that everything is working nicely, and the value is build contract. So what I'm gonna be doing is, so there is one thing, in order to build a contract, a script with the Helios, we're gonna be using one thing that is called the program. As you can see, there is already a reference from the Helios package, new, and then I'm gonna be passing basically the script. This is gonna be my const program. So this is not compiled yet, right? So this is just like interpreted. This object is gonna be very relevant because from here we can then build the datum. I'll show you in a minute. But what we want now is construct and try to compile it. So what we're gonna be doing is lowercase program, compile, and then it asks us if we want to simplify it, so optimize it. We say no. If we remove the simplification, if we put any logging, you can log. You can't add breakpoint, but you can add logs and lots of meta information that are useful to debug your program. But so we are in development mode. We just put false here. Const uplc program is like is const uplc program. So basically that's the compilation of the program. What we're going to be doing is that we are already here. We give npm update just to be sure that we're running the latest version of everything, and then we go with npm run dev. At this point, this is next, that is the technology we're using. This is the documentation to Helios. We could potentially come back to this if we need anything, but all that we have to do now is to go on localhost. We should see just an error, obviously. What did I forget? Cool. It was just like a little issue there. It wasn't an input button, but straight away a button. So the button is now implemented, and obviously there are issues here. Script context is undefined. So let's see into the, there must be, is a little typo here. Context, yeah. So script context is undefined. Let's try again. Boom, that's it. Now the contract is compiling. Now contracts, they also have addresses, so const script address, and you can build an address from, not like this, address from validator hash uplc program validator hash, there we go. And now we can print to console log script address to back32. So now when we build the contract, we will also see that this is going to be the script address of our validation script. We can go on preview Cardano scan. No, there was another one. Preview dot explorer was this one. Yes, this is really nice. As you can see, I've been messing a little bit with this smart contract already. There are some UTXOs, spent and unspent, but we'll come back to this in a minute. So there is already something in here. It's not accessible because I screwed up and I didn't send the datum, so we have to remember this. Now that the script is building, and you can see that the address is published here, we need to continue and build the off-chain code that is sending the assets to the smart contract. So forgot to say that all that you need, and you can check into the documentation of the project, is a wallet in preview with few ADA that you can get from the faucet, or for this one also I'm going to be linking something in the description. And then you need at least an NFT or a token. If you don't know how to mint one in preview, just hit me on Twitter at CryptoJoe101. I'm the stake pool operator of the Easy One stake pool. So if you like what you're seeing, come and delegate to me, because I'm investing lots of time in creating content on how to develop a smart contract in Cardano with Helios. I'm cooperating with Chris to grow this project as well. So hit me up, give me a follow. Then if you want to delegate to my stake pool to support me in this endeavor, and if you don't know how to mint a quick NFT or asset on preview, just hit me up and I'll send you a few of these so that you can mess around, you can play around. So all that we need to do, I don't know if you're familiar with this, but native assets and NFTs are composed by two identifiers. One is the policy ID, another one is the asset name. Because I will not bother integrating with Blockfrost, we will just do things manually. So I'm going to be creating a couple of input fields where I'm going to be entering those data manually without going and inspect the blockchain or my wallet. Obviously, for a production grade software, you will need to do this with the Blockchain Explorer. So just bear with me. So the next thing that we need to do is to get the policy ID, and then the name of the NFT and the asset name is Hello World. So I can build this myself, and we have to build the transaction to send this NFT from my wallet to the script. And this is the next thing we're going to be doing. So we start from a couple of input field, and this is where the input type should have been used. So we're gonna go like this. The type is input, obviously. No, it's text. And then we're gonna be putting placeholder, and we're gonna go like policy ID. And then we need a couple of variables as well. I'm gonna be policy ID set policy ID, and in this case it's just text. And then we're gonna do asset name, set asset name, and this one as well, set policy ID, asset name. So the value here is gonna be policy ID on click, on change event set. This is set policy ID event target value, and then the next thing is going to be the asset name on change set asset name, and here is going to be asset name. We can now start to build the send to vault. Send to vault again is an async function. We accept require 0 params, and then we're going to be basically copying and paste this little bit of code because it's going to be useful. We're going to be reusing it. Now the next thing that we have to do, actually I forgot to say something. Whenever we start the program, we also need to connect to the wallet. So one thing that we will need with the Helios is a reference to the wallet. We're going to be putting it down here, and then it's going to be wallet. We call it wallet API. Set to wallet API. I think this is going to be a CIP30 handle. I will check in a minute. I can't remember the exact type. But what we're going to be doing is, don't do this in production code. You will need to do this a little bit more in an elegant way, and just basically attempt to connect every time that the page is loaded. Production, you need to do nicer things. Here, just taking the happy path. So what I'm going to try to do is Cardano, window Cardano Nami enable. So this is an async function, so I need to give it a wait, const handle await. This is gonna give me a CIP30 handle. Then from the CIP30 handle, I can build a new wallet API in this way, const. Actually, I think I am CIP30 wallet helper. I think I'm happy with this. No, I'm gonna still be wrapping it. I'm gonna be cheating and I'm gonna be copying this thing here. I'm gonna be taking a reference to the handle. Yeah, it makes no sense to just save that one. So we get the handle. This is basically the API that is returned by every single wallet. I'm gonna be wrapping it into the CIP30 wallet that is implemented by Helios so that I can set this thing. Of course, so I just need to set now the type like this, and this should work. Let's go to the page. The page reloads. There are no errors. So now that we have a reference to the wallet, we can build a new object that is very useful. It's called wallet helper. That we're gonna be using. Because wallet API could be undefined, we have to wrap it in an if to be sure that the object is defined, and basically we are ready to start to write the off-chain transaction. Obviously we need to build a transaction, so we have const tx equals new tx. Obviously we take it from the Hyperion package. What we need to do is to add an input, add inputs. So we need now to select the UTXOs from our wallet in order to spend the NFTs. So this is going to be like a little bit complex, because now we do know that the wallet helper has a nice feature that is pick UTXOs, right? And it accepts a value. Value is basically ADA or assets that you want to spend. Any transaction, you can use this pick UTXO as a facility method to quickly select the UTXOs that are required to satisfy that value. Now our value is going to be a little bit complicated, so we need a couple of ADA. We're going to be using exactly 2 ADA and an asset. We're going to be putting into the value. The asset is the NFT or native asset you want to send. So let's try to do this. Const value equal new value. Now value accepts 2 things: the amount in Lovelaces and then the assets. So the amount in Lovelaces is specified with a big int. I'm going to be using this notation to select 2 million. In this case is Lovelaces. So we will do in this way. Now the next thing that you have to do is provide assets. Assets are a little bit cumbersome to build, so let's do one thing at a time. In order to identify a native asset, we need the minting policy hash. So const minting policy hash equals minting policy hash from X, and this is exactly what we are gonna be getting from the inputs field, that is the policy ID, and we get the policy ID. Now we need to build the actual asset. So the first thing that we're gonna be doing is the asset name. Const asset name. Did I declare this one already? Yeah. So we call it just name. That is going to be, we need to X encode what we got from the from the input field, that is the asset name. So we're gonna go buffer from asset name, and then we need to encode to hex. We can use this really nice and neat notation. So that's how we do it. And now we need to build the assets. So in order to do so, we just build the new assets. Is it from the Hyperion? Yes, this comes as a list. So we're gonna use square bracket notation, and then it's a list of lists. We need to use MPH, that is monitoring policy hash, and then again list of lists when we get the name of the asset, and then big int for how many assets. In this case, we pretend that this is kind of like an NFT. So this is the value that we want to spend, 2 ADA, and then just like one NFT. And the NFT is literally this hello world that I have right here, and we want to spend it. So in order to do so, we want to select the UTXOs that contain this thing. We have a nice facility. Again, this returns a feature, so we're gonna go like awaits const UTXOs. So whenever we call the pick UTXOs returns all UTXOs available into the wallet, but split in 2 parts. A list of UTXOs that satisfy the requirements that I just passed in for the value, and then there are all the other UTXOs. So this is really important because we can use UTXOs 0 to for the input, and then later on we will call a finalize, and we can already do like network params, and then change address. Again, I think I can take it from the wallet helper. Change address, is there a future, is a promise, so await again, and then I can pass the so-called spare UTXOs, so UTXOs this time 1, just in case those one are not enough to pay, for instance, for the fees. Since we introduced it, we also speak about, finalize. Finalize basically balances the transaction, so looks after the fees and all the other things, yeah, computes, if you're using a script, how many fees we have to pay for memory and for memory and CPU. Also, network params could be undefined or null, so we're going to be wrapping this into the if conditions. Right, so the inputs are done. Now we need to add output. And for output, I think 1 is enough. We need a new output. Now the most important thing here is that we need to send something to a script address. We don't have to forget the datum, because if you forget the datum, whatever we are sending to the Cardano blockchain is lost. Can't be withdrawn anymore. Just bear in mind, you're sending stuff to a script address, you need a transaction. You do need the datum. So let's build this transaction output. New tx output. So let's see what it wants. It wants an address, and we have it because it's the script address. And it wants a value that we just have there, and then you can see there is a datum, and we're going to be specifying it's going to be the datum is going to be of type inline, but actually I think I still have to import, so this is automatically done. Inline, now it accepts some data, but we haven't built the datum yet. So let's go and remember what shape is the datum. Datum is just a struct with just one property, that is the public key hash. Now, another thing is absolutely beautiful about Helios is that you can use now the just digested version of, interpreted version of the script to build the new types. So you can go like program types, datum, and then you can do new, and then pass the things that you need. In this case, it's just our wallet, base address, public key hash. So do we have the base address yet? No. So we're gonna go like wallet helper, base address. We're actually gonna be doing something like this. I'm gonna be storing this thing in the const base address like this, and we're gonna put an await. And just for the sake of educational thing, base address, we're gonna be printing it base address, but we have to back 32 because this is like the notation test to address 1, test 1, whatever. Right. Of the base address, we need the public key hash. We just need to do something like this: const datum equals all this beautiful stuff here. We pass it to it, and we're basically done. Input, output, finalize. One thing that we have to add is the signer. So in order for the public key to be seen by the smart contract later on, actually I don't think the signer is actually required at the moment. No, I don't think it's required. No, it's not. It shouldn't. So this is an await here because finalize is a future. The next thing that we have to do is to sign the transaction. So we have to call wallet API sign transaction, that is TX. Here is const signatures sign, and I have to put an await because it's a future again, and now into the DX is add signatures. And then we're ready to go. Let's see. Let's take the policy ID. We'll put it here, and then the name of the NFT is hello world exclamation mark. Oh, I forgot the button. Another thing that I need is the button here. I'm gonna be calling submit. Send to vault. Now the button is magically appeared, and let's see what happens. Wow, that was impressive. You can see that our base address is the following one, so on and so forth, but Nami has already received the transaction. It's saying that we are spending 2 ADA and 18 cents, and we're sending one assets somewhere. The details are here. The recipient is our script address, UUS, you remember, signing keys, payment, tags, whatever. Back, sign, let's see if it works. Well, that looked like it was accepted, no errors. In the meantime, the transaction gets accepted. Whenever you have the submit, you actually have something that is returned. That should be like the TX hash. Again, this is a future, and then we can go like console log the TX hash. Obviously, we're not gonna see this thing anymore. Just for your reference, if you wanna see the transaction hash. The transaction hash actually I'm gonna be showing you in a minute, because it's nothing else than the UTXOs where the NFT is sent. And now you can see that magically there is a new UTXOs. It is exactly the one that we just sent. 4663 is the sorry, 4290, this is the old one. 4290 is the policy ID that we just sent. Oh my god, it's just worked, and this is the transaction that we just sent. Now, it's really, really important that you know that this is our public key hash, and we are the only one who can get this stuff back. Because this is the public key of the keys that have just signed that transaction. This is a parameter within our smart contract, and if whoever is going to try to collect this thing is not us, they can't. So what we can do is now we gonna be implementing like the collect feature, and in order to do so we need to do a couple more things, yeah, let's get stuck. So what we need to do is that now we have to spend this UTXO, and we need to collect those information, the hash and the index. I think there is no need to do the input type fields. We can just like copy and paste the code. So let's start to write the thing straight away. What I want to do is just like create a new button that is basically withdraw. So new function. As usual, no attributes required. You're gonna be cheating and copy a little bit of this, but we will need to rejiggle a couple of things. So we know the program, the UPLC program, the script, wallet address, wallet API, network params. We need to know the value, definitely we need to do the value. We need to do, actually, let's start to build the transaction straight away. And then we reverse engineer what we need. I don't think, yes, we still need the datum. So what we need first is to build the UTXO, that in this case is going to be the input. So the input in this case is the UTXO we want to spend. So new UTXO. UTXO wants a TX ID and UTXO ID. So new TX ID, that is a string, and we can get it from here. The next thing we need is a big int with the UTXO ID. That is, sorry, let me check the brackets. That is exactly 0 because the index is 0. Now the next thing that we need is another bracket, definitely, and then the TX output. So what's inside the script, the UTXO. Let's see what are the things that the TX output wants. Editor, why are you not helping me? Address, I think he wants the script address, and we have it. The next thing is, oh, that's it, new. The new address, and we have it. The next thing is the datum, and we have it. Again, is in inline datum, and then we need nothing else. Why is it not happy? Takes output once script and so value must be a value. I actually don't understand why the address, value, there we go, sorry, address, value, and datum. There we go, sorry, that's what was missing. So this is the input. We need additional input because we need to pay. So this time around we don't need obviously the asset anymore, and we're going to be selecting a smaller UTXO, so just one ADA, just to have a few money to spend. Another input is done. Now we need the output. The output in this case is going to be our own address because we want to get this thing back. So we're going to be using, I will send it back to the base address. So we have the base address here. There is not going to be any datum, obviously. And the thing that we want back is exactly the value that we want to collect from there. This time we have to add the script as well. UPLC script, sorry. The UPLC program. Is that it? In this case, because we have to check the signature that is sending this thing, we also need to add our own prior key. We need to add the signer, that is ourself, and it is again base address pub key hash, and this is required. So again, this should actually do the trick. We take the name of the function, we'll put it here, and let's see if it works. Right, so this is really important. One thing that I forgot, and luckily Helios is telling it to us, is that the input is actually locked by a script. It's really important that we always provide a redeemer. I completely forgot to add the redeemer, but because we didn't specify any redeemer into the main script, we can pass an empty redeemer, and that's exactly what we're going to be using. So there is an object called the const data that is basically used to build arbitrary objects, UPLC objects. In this case, we're passing 0, that is null, and an empty array of data. So that should actually do the trick. Is it safe? There we go. This is saying though that I am only gonna get 81 test data, and there is no yeah, so sorry, I made a small mistake here, right? You remember when I changed this value, changed the value for the withdrawal? That's not what I wanted to do. I still want to pick, this is the value I want to deal with, but when I pick UTXOs, I need the new value that is just a million Lovelaces. Oh, come on. Because that's not what I want. In fact, well, I was still authorized because I was authorized to spend it, but I wasn't authorized to, it's not what I wanted. Let's try again. That looks better. So because there are going to be 20 cents spent in fees, it's not going to be the original 2 ADA, and the fees are going to be taken straight away from the contract, because already there were 2 ADA inside, so I'm not going to be spending anything. And in fact says that 1995 whatever are going to be done by the going to be used as a fee. So before continuing, I happen to have also another wallet that is the following one. So let's try to see first of all if this thing is working. So there is a little change that we need to do into the code, because a little change because we have to instead of computing the datum on the fly, that is this one here, taking from our public hash, we need, that is the public hash of the current wallet, we actually need the public hash of the one that submitted the wallet. So I'm going to be getting, this is the original wallet that locked the data. So what I'm going to be doing is create a new address from back32 const, and we call it authorized address, and we use the authorized address public hash to try to withdraw the token. So let's go again here, and I'll show you that if I try now to withdraw the token with another wallet, this is going to give me an error because it's going to tell me that I am not the owner. I do have enough ADA to pay for the transaction, so I should be able to do the withdraw, and that's it. Is owner false? So we are not the owner. The validation is actually working, and it's preventing me from getting our tokens locked into the vault from a different wallet. Let's see if now I can actually withdraw from my own wallet. So we launch the transaction, we sign it, we submit it, and there we go. We finally managed to submit the transaction. We see that there are 2 UTXOs here. In a few seconds, the one on the top will disappear because the content of this UTXO, that there is like a nice NFT here, will just come back into our wallet, and that's it. It's just disappeared. If I go back here and I open my wallet, we will see that I have actually managed to send to get the Hello World back token from the script into my wallet. So that's pretty much it, guys. The code is available on GitHub. Again, link in the description. I really hope you enjoyed. I wanted to code this thing live and make it a little bit shorter, but obviously the on-chain part is really small and it's super quick, while the off-chain part, as you can see, is a little bit more cumbersome. And if you want to make it production ready, it's going to require a little bit of time and integration with other APIs as well. So just remind you that I'm stakeable operator, easy one stakeable. If you want to support me and my channel and all the content I'm creating, please delegate to the Easy One Stakeable. Check the easyonestaking.com website as well, because there are a few initiatives, raffles, airdrops of WMT, World Mobile Token, and NTX as well. Any questions, let me know. I'm still a really beginner of Cardano smart contracts in general, and helios as well. So please apologies if I made any mistakes along the way. Thank you very much and have a great day. Bye.